Hey guys, welcome back to my channel. This is Torpan solving all of the pawn challenges from CSICTF. And before getting on to the first pawn challenge, all the timestamps for each of the challenges are given below in the description. And also, if you have doubts regarding all of the challenges or any challenge, you can basically contact me with the below given Discord server. And with that being said, let's just start with the first challenge. So I have named it as pawn 1 just for my convenience, and I will run the challenge first, or the binary. um, it says please pour me some coffee. Okay, let me give it 1, and let me try to analyze this in GDP peda. So you guys can use any extension of GDP. I like peda personally. Let me disassemble the main, and we see some set buffer that's like basically for the Docker files, something like that. We are not interested about that, and there's a put statement probably for the pour me some coffee. And this is the guy that gives us the vulnerability, that is gets is actually a vulnerable function that takes an arbitrary input. That is, it does not check on the size of the input, it just takes everything in. So we have a potential overflow there, and it's calling puts here. So one more printf, and it is checking rbp minus ox4. If it is equal to 0, then it jumps to main 151. So one amazing thing we can do is there's a system here, and let's also see what is the argument to the system. That is by x/sh this. Okay, that's pretty cool. We need the flag.txt, so basically we should not take this jump. So in order to skip the jump, we have to overflow to rbp minus ox4. So giving arbitrary value would be enough, I guess. Let's try it out. Python taxi print a about 200 times, and let me take their netcat server because I don't have the flag.txt. Oops. 3001 3 not 3000 30,001. And yeah, we do have the flag for the first challenge. That was pretty cool. Let's go to the next challenge. So let's start with pawn intended ox2. So I have already downloaded the binary, and I have marked it as executable so we can run it, and it runs fine. So we can try to disassemble it with GDP peda, something that I like. So as usual, there's some set buff which we don't require, and there's a puts with an argument, and again there's a gets. So it's again vulnerable, as I said, because it takes arbitrary input. But this time, instead of rbp minus ox4 is equal to 0, this time we have to make rbp minus ox4 equal to cafe babe, so that they will be equal and it continues without taking the jump. Else, if rbp minus ox4 is not equal to cafe bay, then jump not equal to 154. We basically land here and we take the return. We don't get the system. And as you already know, ox402070 is most probably going to be cat flag.txt. Yeah, so our aim is to basically overflow to rbp minus ox4 and make it as cafe babe. So I am going to do this with just the command line. I'll first import pawn tools. If you don't know pawn tools, it's a great tool to interfere with the binary, and also it also helps us to create patterns to find the offsets, like what I'm going to do right now. So import pawn, and I will print pawn.cyclic about say 200. Yeah, so we'll make it into a like a file, and we'll make GDB run with the file a. Okay, I got a segmentation fault. Let me just put a breakpoint here, and then let me run with A again. So yeah, now let's do x/s $RBP plus minus OX4, right? Yeah, so that is equal to this this weird pattern. So let us again use the pawn tools library to find out what the offset is. So cyclic find, and this pattern, so it says in order to get to RBP minus OX4 you have to write 44 bytes in front of it so that you can manipulate the value at RBP minus OX4. So knowing that, let's directly jump on to the solution. So basically I'm importing pawn, basically importing everything from pawn, and I'm connecting to the remote server at the port 30,007, and I am sending a line that is 44 times some garbage value, and then I'm sending this value in the form of little Indian, because when we check sec this pawn 2 we get it is little Indian MD64 64-bit little Indian. So that's why P64 in order to convert this to little Indian, and I'm making it interactive just in case. So run this, and there we got the flag. Let's go on to pawn intended 3. So coming on to pawn intended 3, we will see how this challenge goes. And I've already downloaded the binary and I've marked it as executable. So let's run the binary, and it's time for teleporting again, but we get nothing this time. So okay, let's go to GDB peda for analyzing the binary. PD main. Okay, the usual set buff, and one puts and one gets, but there's no system. What can we do right now? First thing I do is I used to do check sec. Okay, so NX is enabled so that we can't write any shellcode and execute it. So the next thing I check is for functions. Nice, we do have a flag function for EC shell or EC root. Let me just see what that is. So it has some kind of a system, so let's see what exactly that does. Okay, it's again going to cat flag.txt. So basically our idea is to use the gets vulnerability in order to overflow the return address and basically make the return address jump to the flag function and basically give us the flag. So first thing first is finding out the overflow. So in this case it was pretty basic, so I just had to use the inbuilt function of GDB peda that I really love, that is pattern create. I'm going to create a pattern of 500 characters and I'm going to save it in pattern, and I'll run it with pattern, and we get a segmentation fault as expected. And let's do a pattern search. So basically we can see that RSP is at an offset 40. So basically what that means is we have to write 40 characters in order to reach the value of RSP, and our aim is to make the stack pointer point to the flag function. So 40 bytes of garbage value and 8 bytes of the address of flag function so that we can jump there. It was pretty basic and there were most number of solves for this, so I'm not going to waste more time. So let's start writing the code for this. From pawn import everything So p dot send line 40, right? A into 40 times, and we need to do this in little Indian, and we also know that it was 64-bit. And let us do readelf tag s on the binary so that we can see the flag function address. So ox and that, and then p dot interact save. Let me run the binary, and there we get the flag. So that's for pawn intended ox3. So coming back to the pawn 4, this was fairly easy. You just had to know the concept of string cat, that is appending one string onto another. So this was our secret input, and it was also being used by fgets to input. That is about ox 80 characters, 80 bytes with standard input, and then there is the flag.txt of size ox32 probably, because it is loaded into local 58. So we can say local 58 is our flag buffer, and local 58 is right here, and our input buffer is right here. So we also have a buffer overflow. So basically when we give a huge amount of input to local d8, after string cat, the null byte will be moved on to some further place onto the stack, because each string is differentiated with the help of null bytes. After each string there will be a null byte. So if you do puts for example say a string, it will print till the null byte. So because of the string cat, after the append, we actually also append the flag.txt as its right on the right position on the stack. So that can be a potential attack for us. So as you can see, I've already tested it out on my local server and the netcat server. So let us run the binary, and we can see we have some input, and string cat is basically appending this string, that is these three things, onto our input. So if we input a very large amount of data, then it will accidentally print the flag along with the input, because the null byte will be shifted. So let's say 500, and let's give nc, yep, and there, as we thought, we got the flag. Coming on to the next pawn challenge, that is going to be global variable. We see that there's a login function already. Let's go to the main function. There's nothing interesting because there's a array of 1024, and fgets is also ox400. I assume they are same. We'll check it out anyway. ox400, yep, they are basically the same, so there is no potential overflow there. So there's a login function with the variable local 410, that is our input. Let's go there. So here we see that our input parameter 2 is being printed out, but there is actually a problem here. It is printing our input as a format, so we can basically control the format. So there might be a format string attack possible in this case, and we can already see that there's a system cat flag.txt, and then if admin is equals to this, and this doesn't seem like a real value, so we'll statically analyze it in GDB. Coming on to GDB beta for getting this value and the admin, and such things. Let's run it and let's confirm that we have a format string. Yes, we do have a format string. Let me do pd main login function. Okay, so this is the value that they actually want. So let me just store it here. Yep, already there. And then we need to find where exactly the admin variable is. We can't do that. I'm just kidding. We have to do info variable, because since admin is a variable, it will be here, and I think I saw that. Yep. So this is the variable. This is the position where admin variable is located. Now it's all finding. Let's try finding the where exactly our offset for the format string is. So I will be using 4A's because this is 32-bit, and then I will be appending this with %p in order to see the hex values, and then I will do it like 20 times, and then I will use the I'll use the function, I mean the binary. So in this case we can already see this is our input. So let me calculate the offset manually. So 1 2 3 4 5 6 7 8 9 10 11 12. So it's at the 12th position, so we can also write it as 12. And if you don't understand this code, just hang in there. I'll explain it to you guys in a simple way. Now coming back to this is the variable that so I guess this is the position where admin is located, admin variable, and this is what we need to write it into. So there's actually something called as a %n and things like that, but Pawn Tools has made our job easier. So it has a inbuilt function format string payload, which takes the input, that's the offset, and then a dictionary which contains where to write, that is the admin variable, and what to write it with. So fairly easy. Again, let's run it, and there we have the flag.txt. Now let's make this run on the remote server also. So there we got the flag. It was pretty simple. Now let's jump on to the last function. So coming on to the last binary exploitation challenge or pawn challenge, this is the binary in Ghidra, and then we have the main function, which is nothing much particular here. There is some malloc and some realloc, and I especially thought this was a heap challenge, but seems like there was an unintended solution. Going on to say hello, we have a string copy which is very vulnerable because it does not check the size of parameter 1, and in this case parameter 1 is our input. So we can write arbitrary amount of input to local 88, so more than 128. So what I did is a libc leak. Basically I called puts with puts so that I can print the puts, and then jump back to main, and then I calculate the offset of the libc, and then I get the flag. So let's see how I did that. So first things first, I connect to the remote server, and then I load the binary, and then I have puts at plt calculated already with the help of this command. So object dump tag d pawn6, you get the address of puts at plt, and you need main after this, so address of main, and then do tag r for the got address of puts, and there you go. I have calculated all of these three, and then our first task is of leaking memory. So this is not needed. I guess that's needed. Yeah. So I just print what we receive from the binary, and then we make a buffer of size 128 plus 8. This is going to be our offset to the return. I am not wasting time calculating the offset. And then we basically puts at PLT onto the stack, and then main at PLT, and then the puts at GOT. So main at PLT is like our fake address, but in this case we really need to go to the main function. So puts will print what is on puts at GOT, so basically printing the address of puts at GOT. And why do we print puts at GOT is because in the binary usually puts at GOT is the puts at the libc. So leaking the address at the libc puts will give us the base address of the libc, and then once we jump on to the main address, once we jump on to main, we do a send line of buffer that is giving all of these input, and then doing a receive line. I did a 3 receive lines because I was testing, and then I printed it, and that's the first stage. Now and there we go. This looks like a legit address for a puts. So I'll be using the libc.lookatme, and I've put puts and the last 3 digits of the function address, and there we go. We got the correct libc, so we don't have to do anything else. We have the offset for all the functions inside the libc, and then we can also have the base address of the libc eventually. So yeah, so I noted down all of the offsets. Yeah, so the 3 offsets from here, and then we know that puts address of puts we know, so we can basically calculate the libc base by subtracting the offset from the libc leaked puts, so thereby getting the libc base. And after that it's pure joy for us, because we just have to add the bin sh offset to libc base, libc base to the bin sh offset, and again the same for system. And then again, since we are again in the main function, as we did this, it goes back to main, and basically we do system and a fake address, and then bin sh offset. So it will execute system with the argument bin sh offset, or bin/sh to be more specific. I just rerun it, and yep, we got the perfect shell, and we can just cat flag.txt and we'll have the flag. So that's it for this video. We'll look at the next CTF.